Hello students, let's start with a new chapter. This is chapter 6 of your textbooks, Lines and Angles, and the topics to be covered are Introduction, Basic Terms, Intersecting and Non-Intersecting Lines, Pair of Angles, Parallel Lines and Transversal, Lines Parallel to the Same Line, and Angle Sum Property of Triangles. Now some of these topics must be sounding very familiar to you, while some not, but you will see as we proceed with this chapter while solving sums and basic definitions that I will be giving you, that this chapter is not just very easy, but it is also very scoring. Now why are we learning lines and angles? Because it is going to lay a foundation for geometry. So what is the importance of learning lines and angles is that it's going to lay, first of all, it's going to lay a foundation for geometry. If you plan to take up architecture or design, then it's going to come in very handy. For example, if you're planning to take up architecture, you need to find the basic thing. You need to find the height of a particular tower from, say, this point. Obviously, you're going to measure this length, Obviously, you will see that this is a right angle triangle over here, this section. So when you know this, let's say x, and you know y, you can obviously find the length of this tower. How? Using Pythagoras theorem, wherein the hypotenuse square is equal to y square plus, let's say, this length is z. So if I have this as 10 and this as 5, the value of z would be, z square would be, or z would be under root of 10 square minus 5 square, which is 100 minus 25, which is under root of 75, and you can find the value of root 75. So this will be the height of your tower. So this was the most simple example how you will be needing it in the field of architecture. Even while drawing, if you're designing something, while designing you're always not going to just draw curved lines, right? You will need straight lines, you will need angles, and you will need other geometric terms such as quadrilateral circles, but that will follow later in the later chapters. So this is the importance of learning lines and angles because it's the basics, right? So let's start with the first topic that we were supposed to cover, which is basic terms. So the basic terms that we will be looking at are line, ray, line segment, collinear and non-collinear points, angles. Now there are different types of angles. Angles are categorized under different names. So these are acute, right, obtuse, straight, reflex, complementary and supplementary, adjacent, linear pair, vertically opposite. Many of them you must have learned in your previous classes, and it's going to be a repetition, but we are revising it so that we put this all together and your notes are compiled and you can relate to the new terms that you will be introduced to. And then the other topics are intersecting and non-intersecting lines, pairs of angles. So these belong to the basic terms category. So let's start with line. What is line? So let's draw the line to understand it better. A line looks something like this. It's obviously a geometrical figure, correct? It is straight. These two arrows, they indicate that the line is going to extend indefinitely in both the directions, and this breadth, if you see this breadth, it is extremely small, or it is indefinitely small. So let us now write down the definition of a line. A line is a geometrical figure that is straight, it extends indefinitely in both directions, and has infinitely small width or breadth, or let's say thickness. You can write thickness or width or breadth. By each of these terms, width, thick and breadth, I mean to say this. You can see that I have drawn this with a chalk, that is why you can see it, but lines are going to be infinitely they're going to be infinitely long, and the thickness is going to be very minimal. So that's why infinitely small thickness. Okay. The next term is ray. So what is a ray? If I cut this section over here and I put a point, doesn't ray become this is a ray? So isn't it a part of a line which has a single endpoint and extends indefinitely in one direction? So what is my ray? My ray is a part of a line which has a single endpoint and extends indefinitely in the other direction. So let us write down the definition for ray. Part of line that has a single endpoint and extends indefinitely in the other direction. So this was about ray. Now if I cut this side also, the arrow, and I put a dot here, that's a point. So what happens to my ray? First I cut one side of my line to give it a single endpoint to extend it indefinitely only in one direction. So that was my ray. Now I cut the ray and I put up endpoint over here, right? So what happened is, now this portion of your line has finite length and it has two endpoints, and obviously it's not going to extend indefinitely in any of the directions. So therefore it is a line segment. Line segment, first of all what it means, you're cutting something. If suppose you have, let's say, a chocolate bar, this is your chocolate bar, and you cut out two pieces from here, that's 4 pieces in total, but 2 vertically. So this portion that is cut out, it is a segment of this chocolate bar. Similarly, you have cut out a segment of the line, that is why it is called a line segment. Why? Because now it's not going to extend indefinitely in both the directions and it is a part of the line. So let's write down with the definition for line segment. It is a part of line that has finite length and 2 endpoints. So we've done with line, ray and line segment. What about collinear and non-collinear points? So collinear points and non-collinear points, there is a very basic definition. See, first of all, if I have this line over here and I place another point over here, so I have 3 points, 1 point, 2 point and 3 points. Now these 3 points are lying on the same line. So when they're lying on the same line, that is why they are known as collinear. That means first of all collinear. Let's split it up. You have co-linear. Correct? Ignore the extra L over here. Co means in cooperation with and linear in one line. So it's in cooperation with one line. That is why it is collinear. And obviously non-collinear is going to be what? Any other third point that does not lie on the same line. So any 3 points that do not lie on the same points. There will be 2 points obviously lying on the same line, but the third point is not lying on the same line that is connecting the other 2 points. So this is the definition of collinear and non-collinear. Let's write down our definitions. any 3 points that lie on the same line. And then you have non-collinear. It is any 3 points that do not lie on the same line. Correct? Now first of all, before proceeding with collinear and non-collinear, I just missed out one single point related to line ray and line segment, which is earlier you must have learned that line, if suppose I have this line AB, if this was line AB, it is represented as AB with a line on top of it with 2 arrows. If this was a ray AB, it is represented as AB with a single arrow on the line on top of it. And line segment AB, if this was a segment, it is represented as AB. But now onwards, we won't really be using these notations. We'll be just representing your lines, rays and segment by using small alphabets such as L, M, N, anything but small alphabets. You will see and you will understand as and when we proceed further. So this was a small point that I missed to mention about line, rays and segments. So we're done with collinear and non-collinear points. Now angles. So let us first draw what an angle looks like. My angle, it looks like this, or it could look like this, or it could look something like this. Correct? So what do you see? There are many other types. So what do you see? The basic things that you see is that you have 2 rays. Correct? There are 2 rays and they are originating from a single point. So what is the definition of an angle? It is a geometrical figure wherein 2 rays originate from a single point. Now this single point is known as vertex, and each of these arms are known each of these rays are known as arms. So what is your angle made up of? It is made up of 2 arms connected by a vertex. So let us write down the definition for angles. A geometrical figure where 2 rays originate from a single point. Where the point is called vertex. The singular is vertex, and if there are many points, they are known as vertices. So we have a single point, that is why it is vertex, and the 2 arms or the 2 rays are called the arms. So the basic definition of angles. But now over here you see that there are different types of angles. So let's start with this first category, wherein you have acute, right, obtuse, straight and reflex. So let's start with acute. An acute angle will always look something like this. First of all, if you have seen your protractor, if this is your protractor, what do you have? You have a center 0 here, you have, so this is the center here, you have 0 degrees, you have 180 degrees and you have 90 degrees here. So your acute angle will always lie between 0 and 90 degrees. So it could be this angle or this angle or this angle, that is along with this line. So this is your acute angle. So let's say I call my angle ABC and this angle as X. So X is going to lie between 0 and 90 degrees. This is my acute angle. Then I have my right angle. Your right angle will always be 90 degrees. So this is your right angle. So this is my right angle ABC, and right angles are denoted by a square over here. Not really a square, but something like this. Correct? So A, B and C. So if this is your angle, let's say y is going to lie between, y is going to be equal to 90 degrees. It's always going to be equal to 90 degrees. And then obtuse. So what is an obtuse angle? An obtuse angle will always lie between 0 and 180 degrees. So it will look something like this. See, if you see, this is going to be your right angle here. So it is always more than 90 degrees and less than 180 degrees. From here to here is 180 degrees. So this is my angle ABC, and this is, let's say, I'm denoting the angle as Z. So Z is going to lie between 0 to you can say it's going to lie between 90 degrees to 180 degrees. Why not 0 to 180 degrees? Because between 0 and 180 degrees, I could have an acute angle or right angle. That's why I'm specifying that it is more than 90 degrees, but it is less than 180 degrees. So this is my obtuse angle. And what is straight angle? A straight angle is wherein you have a straight line. And the measure of your angle here, A, B, C, let me call it P. So angle P or P is always going to be 180 degrees. Right? And finally I have reflex angle. So what is reflex angle? I think this is a new term that you're being introduced to. I have this triangle A, B, C. So this is your acute angle, and whatever is left over here, I'm denoting it with double line. It is your reflex angle. So your reflex angle is going to lie between 180 degrees and 360 degrees. So if I'm denoting, I'll say this is, I'll write B over here, and let's say I call it Q. So Q is always going to lie between 180 to 360 degrees. Why? Because you can see here, it's not a complete circle. A complete circle is what? It is 360 degrees, right? You must have learned in your previous classes that the angles in your circle, when you add them together, it is 360 degrees. So an entire turn is 360 degrees. But this is not an entire turn. It is less than 360 degrees, and obviously you can see that it is more than 180 degrees also. So reflex angle will always be 180 degrees, between 180 degrees and 360 degrees. And while solving your questions, if you are given your acute angle, if you are given angle B, then it is very easy to calculate angle Q. How? You're just going to say angle Q is going to be equal to 360 degrees minus angle B. So if let's say my angle B was 30 degrees, so it would be 360 degrees minus 30 degrees, which is 330 degrees. So this is a very important point, because while solving your questions in the first exercise especially, you will notice that you will have to find the value of your reflex angle. You're going to use this same formula to use it, that is 360 degrees minus the acute angle that it makes. You can see, obviously if you see over here, this is angle ABC, the acute angle, even the reflex angle is angle ABC, but it is the larger one. That is why reflex. Okay, now we have to proceed with complementary and supplementary and the rest of it. So I'm erasing this section. I hope you've taken a note of it. So because I need space to explain this further to you, so I'm erasing all this. So now we have reached the major category of angles, which is complementary and supplementary. So let us see what is complementary and supplementary. I have drawn angle ABC, and there is another angle over here. There's just a ray over here. You will see why I have done this. So I have drawn two figures over here, wherein ABC is a right angle and PQR is a straight angle. Alright, so when I denote any angle with a box over here at the center where the angle is made at the vertex, it is always a right angle. But what do you see? You see something extra. There is this ray BD. Over here also you have this ray QS. So what is what is happening over here? I can see that there are three angles. First angle is angle ABD, then I have angle DBC, and I have the whole angle ABC. So can't you say that ABC, angle ABC is equal to angle ABD plus angle DBC? But this is 90 degrees, right? So angle ABD plus angle DBC is equal to 90 degrees. So what is the definition of your complementary angles? The sum of if the sum of two angles is 90 degrees, then the angles are said to be complementary. So this angle alone is not complementary. These two angles, when mentioned together as a sum, they are complementary because their total is 90 degrees. Similarly, now let's proceed to the next figure. I have three angles here as well. So what are these three angles? I have angle PQS, I have angle SQR, and I have the straight angle PQR. Here if you see, angle PQR is what? It is the sum of angle PQS and angle SQR. But this is a straight angle. And what did we learn just a while ago about straight angles? That their measure is 180 degrees. So this is angle PQR is 180 degrees. So angle PQS plus angle SQR is 180 degrees. So this makes these two angles supplementary. So supplementary angles are what? Angles whose sum are 180 degrees are said to be supplementary. So this one is complementary and this one is supplementary. Right, so let us write down our definitions now. If the sum of two angles is 90 degrees, they are said to be complementary. And supplementary. If the sum of two angles is 180 degrees, then they are said to be supplementary. So this was about complementary and supplementary angles. Let's move on to adjacent angles. The definition of adjacent angles, linear pair and vertically opposite angles is nothing different from having two angles and a relationship between two angles. So these three definitions are just to denote relationship between two or more angles. So let's say if I have an angle ABC and there's an extra ray over here D. So what do you see? You see three angles over here. One is ABD, DBC and the other one is ABC. So there are three angles. But if you take into consideration this angle and this angle, what do you see? You see that there is a common angle between, a common ray between them, correct? This is the common ray and a common vertex. So what are adjacent angles? Adjacent angles are combination of two angles wherein they have a common ray and common vertex, and the uncommon arms, or you can say common arm, and the uncommon arms lie on the opposite sides of the common arm. So let us write down a definition for adjacent angles. So before writing down the definition, what are my adjacent angles over here? Angle ABD is adjacent with angle DBC. These two are adjacent angles. Two angles that have a common arm and common vertex, and the uncommon arm, uncommon arms lie on opposite sides of the common arm. Or you can say the non-common arms. The non-common arms lie on the opposite sides of the common arm, are said to be adjacent. So from this observation you can even say that complementary angles and supplementary angles are also adjacent angles. But here we are not really striking a relationship between two angles, we are just mentioning their sum. For complementary it is 90 degrees and for supplementary the sum of two angles is 180 degrees. But here in adjacent angles we are mentioning a property between them. That is what is the relationship between the two angles? That is they lie next to each other, they have a common arm and a common vertex. That is common arm and common vertex, and the non-common arms lie on the opposite side of the common arm. Simple. So we have established a relationship using adjacent angles. Now let's check for linear pair. So linear pair. Now again linear pair is going to help us strike relationship between two angles. I am going to use this same adjacent angles diagram of figure to define my linear pair. So if I open up this angle, that is angle the arm AB, I just shift it a little bit such that A reaches here. So the arm BA, which is the uncommon arm, forms a straight line with arm BC. What will these adjacent angles now look like? I will have D here as it is, I will have A here, B here and C here. So what are linear pair? Linear pair of angles are wherein the non-common arms they lie on a straight line, or they form a straight line. Where non-common arms form a straight line or lie on a straight line. So obviously, since these non-common arms are lying on the straight line, the sum of these two adjacent angles, that is angle DBC and ABD, is going to be 180 degrees because this is a straight line angle now. ABC is a straight line angle. Correct? So linear pair and adjacent are done. Now about vertically opposite angles. You must have done this in your previous class also. So let's say if I have two intersecting lines. I have line AB and I have line CD. They are intersecting here. So when they intersect, they form four angles. You can see angle 1, angle 2, angle 3 and angle 4. Four angles are formed that are clearly visible. There are other angles also that are formed. For example, you can say angle, let's say this is the center O, which is the point of intersection. So the other angle is also angle AOB and angle COD. But four clearly visible angles here are angle AOC, angle COB, angle BOD and angle AOD. Now vertically opposite. Let's say I place a mirror over here. A vertical mirror over here. If this is an object that I am placing in front of the mirror, the image is formed exactly opposite. Correct? So these are pair of vertically opposite angles here. Correct? And let's say if I placed my mirror like this and the object was angle AOC, the image would be this. Correct? So there are, when two lines intersect, there are two pairs of vertically opposite angles formed. In our case, the two vertically opposite angles are angle AOD and angle COB, and the other pair is angle AOC and angle DOB. So a very important note is that, see, the image is obviously going to be the exact copy. So vertically opposite angles are equal. So let's write down the definition of vertically opposite angles. When two lines intersect at a point, two pairs of opposite angles formed are known as vertically opposite angles. Also, I am just writing VOP for vertically opposite angles, VOA. Also, vertically opposite angles are equal to each other. So angle AOD is going to be angle equal to angle COB, but you can't say that angle AOD is going to be equal to angle AOC. Why? Because they form an adjacent angle. AOD and AOC are forming adjacent angles. So obviously they are not vertically opposite, they are adjacent. Only the vertically opposite angles are going to be equal. So the ones that are equal are AOD, COB and AOC and DOB. Clear? So we are done with angles. Now let's move on to intersecting and non-intersecting lines. So let's say I am drawing two figures now. One is this and one is this. AB, CD. AB, CD. So what have I really done? I have two lines in both the cases. I have line AB, line CD, line AB and line CD. In the second one, if you see, you can clearly see that AB and CD are intersecting at a certain point O. Therefore, lines AB and CD are said to be intersecting lines. How about line AB and line CD? You don't really see them intersecting, and if you take this distance between the two lines, it's going to be the perpendicular distance from any point on AB to line CD, or from any point on CD to line AB. If all this distance, if you draw perpendiculars from AB to CD and the lengths of all these perpendiculars are going to be equal, then you will say that line AB and line CD are parallel. So, you have intersecting and non-intersecting lines. If two lines meet at a point, they are known as intersecting lines. Correct? And what about non-intersecting lines? Non-intersecting lines are also parallel lines. If two lines never meet at a point, and the length of perpendicular drawn from any point of a line to the second line is consistent throughout, for all other perpendiculars drawn in similar way, then the lines are non-intersecting. I am just saying non-intersecting or parallel. So this was about intersecting and non-intersecting lines. Now finally, let's go to pair of angles. Pair of angles is something similar to what we did over here, linear pair. Let's see this. I am erasing the board. So let's say that I have a straight line AB. Okay, I mark any point over here, or let's say I just have a straight line AB and I place a ray OD on AB. It forms two angles, angle AOD and angle DOB, and obviously there is another angle, angle AOB. So there are three angles. So since this is a straight line, the measure of angle AOB is 180 degrees. And even these angles, angle AOD and angle DOB, they are lying on this line, therefore they make a linear pair. So if I have a straight line and I draw a ray on it, then the pair of angles so formed are known as linear pair of angles, or you can say pair of angles. If a ray is placed or is drawn on a straight line, the pair of angles, the angle so formed, the two angles so formed are called pair of angles. Also, sum of pair of angles is equal to 180 degrees. How can I say 180 degrees? AOB here is 180 degrees because it is a straight line. Since I placed ray OD on this straight line, there are two evident angles that are formed, that is AOD and DOB. Also AOB is what? Angle AOD plus angle DOB. But from here you have angle DOB is equal to 180 degrees. Therefore, angle AOD plus angle DOB is 180 degrees. Therefore, sum of pair of angles is 180 degrees. So, if you see pair of angles, linear pair and supplementary angles are related. So, with this we wind up the basic terms. We will move on with the rest of the sections, that is parallel lines and transversal and solved examples, and then lines parallel to the same line, angle sum property of triangles, as well as the exercises of your chapter in the forthcoming classes. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting